algebra students, welcome to your flipped lesson. Mr. Lawrence here with your second video on solving rational equations. And again, you can say I can solve rational equations when you're done with this. Now, remember, first thing we're going to do is we're going to look to factor our denominators, right? And I think this denominator will factor right here at the difference of perfect squares. And so that's going to become the quantity of x plus 2 and the quantity of x minus 2, right? Okay, now I can go look for my LCD. All right, looking for a number. Oh, before I do my LCD, I think I am going to do this little thingy. Shoop, shoop. There we go. Now I'll look for my LCD. One number that has to be in my LCD, I need an x plus 2, or 2 more than x. A number that is 2 bigger than x. And then I need a number that is 2 less than x. Okay. And I need a number that is 3 more than x. Okay, this is the first time we've done one where the LCD is a little bit larger, but that's okay. You guys can handle it. So now I'm going to multiply each fraction by this LCD. So I'm going to have an x plus 2, an x minus 2, and an x plus 3. And I'm going to multiply that by all three fractions. And so it'll be here. And I'll tell you what I'm even going to do, just to make it a little more simple. What I got equals 6 over x plus 3. Okay, I'm going to give myself a little bit of room. So I'm going to put that there, and I'm going to spread out my equation, and that was going to equal 6 over x plus 3, and then I had to highlight it, or the underlined denominator, to show it was represented. Okay, and then I have to do it one more time, and I like to put them over 1, right? Just to remind me myself, that they're in, excuse me, they're in the denominator. All right, so now I'm going to go ahead and do a little canceling. I think I'll go with this pretty shade of purple. And looks like the plus 2's will cancel, x plus 2's, and the x minus 2's will cancel. And I'm left with x plus 3 times 1. Well, that's just x plus 3. All right, here the x plus 2's are going to cancel. And I have negative 3 and the quantity of x minus 2, x plus 3. Well, I think I'm going to FOIL this before I distribute. And so I'm going to get an x squared plus x minus 6. Now that's all being multiplied by a negative 3. I'm distributing, right? Can you see how everything we've been doing all year has been building to what we're doing right now? It's a pretty cool thing about math. Nothing is worthless. I mean, if you play the card that, oh, this is stupid, I'm never going to need it, and well, then you're not going to go very far in life because you're going to apply that to anything you don't want to do. I know there were people in my classes at Ohio State that would say that. They wanted to be math teachers. I'm like, when am I ever going to use this? I'm going to teach 8th grade. I'm going to teach out there. I'm never going to teach this stuff. It's stupid. Why do I even know? Well, I've got a feeling they didn't go very far as teachers. Those of us that were there and wanted to learn, we did our best, even when it was difficult, even though we didn't always get A's. And we fought, we scratched, we clawed, we did what we can do to learn. And now we have a much better understanding of math than we would have if we didn't. Okay, and we can help teach you how to have that better understanding. All right, so now I got to multiply one more time, and it looks like these are going to cancel. And by the way, here I'm not going to really FOIL. I am, but I'm going to work really smart. I know that over here I factored x squared minus 4, and it turned out to be the quantity of x plus 2 times quantity of x minus 2. So this is just x squared minus 4. And then, of course, I do have to distribute that 6, and I will get 6x squared minus 24. All right, now, what kind of equation is this? I know Kyle Smith knows this. I've heard him answer it before. This is quadratic. Okay. Whenever I ask you what kind of equation I'm looking for linear, quadratic, maybe cubic, although some of you might not be able to answer cubic because we haven't done much with cubic equations. That'll be more an Algebra 2 topic. All right. On the left-hand side, first of all, I'm going to combine some like terms. So I'm going to go through and find which ones are the like terms. Okay, so let's see, I have an x here and a minus 3x here. Okay, those are like. I've got a positive 3 and a positive 18, and those are like. And then this negative 3x squared right now is not like, notice I'm not highlighting it, the stuff over here because it's on the other side of the equal sign. I'll have to use one of my algebra techniques to move it over, like an inverse operation. All right, so I'm going to put the 3x squared together. What am I writing in poiple? Hold on, where'd my poiple go? There we go. So I got a negative 3x squared. Then the yellow ones are going to give me a minus 2x, and the green ones are going to give me a plus 21. Okay, now it's still a quadratic equation. So I'm going to get everything over to the uh, left-hand side so that my equation will equal 0. So I'm going to subtract 6x squared, and I'll do that here and here. And then I'm going to add 24. Here, let me, oops, what am I doing there? Sorry. I wanted to change the color of these so that they stood out a little bit more. Properties. Ooh, how about pink? Oh, it's kind of faint, unfortunately. There we go. Yellow, that's not bad. And then this one will change also to yellow. All right. And then while we're at it, I'm going to add 24. And here I'm going to add 24. Okay. And my equation will equal 0. Remember, when we solve a quadratic, we want it to equal 0. And so I'm going to get a negative 9x squared minus 2x plus 45. Okay. Well, now it's time to do the quadratic formula on it. I don't think that this is going to factor. I'm sure the quadratic formula will work if there is a solution. So I'm going to do A, B, C. That's easy as negative 9, negative 2, 45. Okay. I'm going to go ahead and figure out b squared minus 4ac, the discriminant, so I know if there are any solutions. If there aren't solutions, then I'm not going to do the whole formula. It would be silly. If there are, I'll know it, and I'll be done. Okay, so I'm going to get 4 plus, and that's 36 times 45. So 45, 36. I'll just show my work right now. Okay, let's see. That's going to be a 30, carry the 3. 24 and 15 is 39, 42, 2, carry the 4. That's 12 and 4 is 16, 20. Wow, 16, 20. And so my discriminant will be 16, 24. And so there are going to be two solutions. So now I'll go to the quadratic formula and I'll change colors just so you can tell what I'm doing here. All right, and of course I'm going to need my my calculator. X is going to equal the negative of b plus or minus the square root of 1624, and that'll be over 2a. All right. Now, right now, I don't know the square root of 1624. I know the square root of 1600 would be 40. So it's going to be pretty close to 40, 41, something like that. But I'm going to need to grab a calculator so I can get a decimal approximation. Hold on one second. Okay, and I got approximately 2 plus or minus 40 and 3/10. That'll be over negative 18. All right, so I'm going to go ahead and do 2 plus that number, and then divide it by negative 18, and I get x is approximately equal to negative 2 and 3/10. And then I'm going to do 2 minus 40.3 and divide by negative 18. And I end up with a positive 2.1 approximately. Now I'm going to go and check. I don't think those are any of my restrictions. Looks like my restriction will be negative 2, positive 2, and negative 3. So there's my solution. All right, let's try another one. This one looks a little bit different. I'm going to factor here, and let me see. I'm going to have to factor that. I'm going to multiply 3 times 8 and get 24. I need 2 factors of 24 that subtract to get 2. Well, it sounds like a 6 minus 4. So I'm going to rewrite this as 3h squared plus 6h minus 4h minus 8. Now I got a little bit of factoring to do here. I'm going to GCF, I'm going to group, right? Remembering that 4 is negative. Put a plus between the quantities. And I'm going to pull out a 3h from the first quantity and get h plus 2. And I'm going to pull out a negative 4 from the second quantity and get an h plus 2. Looks like I have a common factor of h plus 2. And I'm going to get a 3h minus 4. And that is how that denominator is going to factor. Now I'll rewrite it in a second. But before I do that, I have to factor the numerator. Watch what's going to happen here. This one's a little easier because the coefficient on h squared is a 1. I need two factors of 8 that subtract to get negative 7. Well, it sounds like 1 minus 8. So I need a plus 1 and a minus 8. Okay, that didn't really do anything. I was expecting something was going to cancel out. I guess I was wrong, but that's okay. So right now I have h plus 1 over h minus 8. That's over an h plus 2 and a 3h minus 4 plus 1 over h plus 2. All right, and that equals 0. I'm going to go looking for my LCD. And what am I going to need in my LCD? Well, first of all, I'm going to need an h plus 2, right? That'll take care of that guy and that guy. And then I'm going to need an 3h minus 4, and that'll take care of that guy. And so I'm going to multiply both quantities by this LCD of h plus 2 times going 3h minus 4. And of course I have to do it here as well. H plus 2 times the quantity of 3h minus 4. Now here's why canceling out is such a good thing. Because over on that left-hand side, it's getting really ugly until you do this. H plus 2's cancel, and the 3h minus 4's cancel. Okay, the right-hand side simplifies like this. And so now my problem becomes this factored, or FOILed, which is just the original the original polynomial that was up there. Okay, plus 3h minus 4, and that'll equal 0. I'll combine like terms. Looks like I'll have h squared. I'll have a minus 4h and a minus 12. That'll equal 0. Now I could go quadratic formula, but I'm tempted to see if this will factor. Let me see, I need two factors of 12 that subtract to get 4. Ooh, sounds like 6 and 2, right? But I think it'll be 2 minus 6. So this is going to factor as h plus 2 and h minus 6. And then if I just solve, I'll get h equals negative 2 or h equals 6. Now I'm going to go up to my original denominators factored, and so I'm looking, let me highlight them, the ones I'm looking at. Okay, again, nice yellow here. So I'm looking at this before it canceled, and I'm looking at this and this. If h is negative 2, these two quantities will turn to 0. My pretty little crayon here. This quantity will turn to 0, and this one will. So that means that I can't use this answer. It's not one of the solutions. All right. Now, the other restriction is that h can't be 4/3. Well, I got h equals 6. And so there is my answer. All right, one more quick problem. Okay, hold on, let me get a little room here. Looks like we have to factor twice on this one again. Now, last time the factoring didn't do anything for us, but that's okay. This time it's in the denominator, so it's going to be essential. So let's go ahead and factor this. Two factors of 8 that add to get 6. Well, it'll be x plus 4 and x plus 2. All right, cross that out. And here I'm going to get x plus 4 and x minus 4. All right, and LCD. Looks like I'm going to need an x plus 4 in my LCD. It's going to take care of that guy and that guy. I'm going to need an x minus 4 in my LCD. And, oh, the x plus 4 also took care of that one, sorry. And then I'm going to need an x plus 2. And that'll take care of that one. So there's my LCD. I'm going to multiply all three numbers, and maybe I'll make this a little bit longer here, give myself a little room, rewrite it so that you can tell better what is going on. So I'm just writing my LCD. Excuse me. And that'll be over 1. And that's being multiplied by 4 over x plus 4, x plus 2. Okay, now I'm going to need my LCD again. I should put a plus and do that little thing, so I'll put plus. And I have x plus 4 times the quantity of x minus 4 times the quantity of x plus 2. Okay, and that'll be multiplied by the negative 2 over x plus 4. And then finally, I have the LCD, which is quantity of x plus 4 times quantity of x plus minus 4 times the quantity of x plus 2. And that will be multiplied by 3 over x plus 4, x minus 4. Okay, so now I'm going to do some canceling. So maybe I should get my crayon out to cancel. Kind of like the way that looked. I'll cancel in brown. All right, so here the x plus 4 and x plus 2 are going to cancel with this x plus 4 and this x plus 2. So I'm going to be left with x minus 4 times the quantity of x minus 4 times 4. So that's going to be 4x minus 16 plus, get my crayon back out, and this x plus 4 is going to cancel with that x plus 4, right? And so then I'm going to need to FOIL and then distribute. And so when I FOIL these two, I get x squared minus 2x minus 8. And then I have to distribute a negative 2. So I'm going to get negative 2x squared plus 4x plus 16. And one more thing here. That's going to equal, got it, multiply again. Looks like the x plus 4s are going to cancel. And the x minus 4s are going to cancel. And 3 times the quantity of x plus 2. All right, so now it looks like it's going to be quadratic. I'm going to get everything to the left-hand side. So I'm going to have a negative 2x squared. Let's see, I've got 4x and 4x, so I have 8x. I have a negative 16 and a positive 16. Those guys are going to cancel, and that'll equal 3x plus 6. I'm going to subtract the 3x, and I'm going to subtract 6. So, negative 2x squared plus 5x minus 6 is going to equal 0. I've got a hunch that this might factor. I'm not sure about it. 12. Can I find two factors of 12 that subtract to get me 5? 6 and 2, 3 and 4. No, I guess I can't. So I got to go quadratic formula on it. So A, B, C, easy as negative 2, 5, negative 6. All right. I'll do my discriminant. B squared minus 4AC just to make sure they're solutions. And I'm thinking that there might not be. I'm not sure about it, but I'm thinking there might not be. Negative 4, A is negative 2, and C is negative 6. And so this is going to be 25. And 4 times 6 is 24, times 2 is 48. And there's 3 negatives, so my answer is negative. And I'm going to get a negative discriminant. Yippee skippy for me. That means I don't have to did I do that right? Yeah. Yeah, which means I don't have to go any further because I know there is no solution to this problem. Okay, because of the negative discriminant. All right, that's your lesson for today. These problems are pretty involved. You know, the kids who get the A's in the class are going to be the ones that can handle these problems. But if you can't do these problems, don't sweat it. Do the best you can. Get all the partial credit you can. You can still get a pretty good grade. All right, Mr. Lawrence signing off. Good night, everybody.